I'm really excited about this chapter. It's one of those that clarifies and brings together knowledge from a bunch of areas and demystifies a bit the process of what 3D does on its own in front of us. I hope that in the end you find it as interesting as I do too. And this is the final chapter of post-production. Up to this point, we have already gone through pretty much all programs, only leaving DaVinci Resolve out, which we will look at next. With the knowledge you have so far, you can already compose, split and fix the image, do color correction in Photoshop or within Blender and so on. Even in Paintbrush you'll be able to do it. Even within Fortnite, you will now be able to do color grading with everything you're learning. We talked about Cryptomath and compositing limitations in Photoshop so far, but what's the solution then? Well, the solution is to do the composition within Blender itself. Or if you have access to programs that are specialized in this, like Fusion, Nuke, or even After Effects, they will also work. But when using Blender, it will be perfect for those who want to do everything in the same program without constantly having to switch between programs. So in this chapter, I will show you how the process can be faster, more powerful, and integrated. And the best part, the files in 3D become much lighter. In another study I did, only with a 32-bit TF file, it had a resolution of 5000 pixels and a bunch of layers. This file ended up being 4 GB in size. And never will the composition made directly in Blender end up being this large. Look, no more time to waste. If you're tired, imagine my situation, talking non-stop for 3 months while recording these videos. I already explained this, but I will say it again for those who are not paying attention. I can see you there, you know. It is perfectly acceptable to do the grading directly without worrying about the composition. And for that, just use a setup similar to the one we've seen several times. Some lens effects, a slight color correction, save and deliver. The problem is solved. The final composition already receives the denoising effect, so everything is fine. But the individual passes don't, so we have to go through the whole process of manually applying the denoising to each one. It's a pain, right? So, look at this. These are the channels I chose to render now. This image is already the final render, and this time I checked one more, which is the Cryptomath, in object mode. And I have also shown several times that it's possible to do this process in a clean and fresh Blender scene. And then you bring the image of your render to it and do the compositing. But now, to change things up a bit, I will do it exactly after the render in the same scene. So here it is, the viewport with all the objects and the lighting and everything else. And here is the image editor with the final result of this render. Let's first composite the channels back exactly like in Photoshop. And we will start with the node called render layer, that it already comes by default, but I will add it again. Ctrl-Shift and click on each one to see if it's working. And there it is. All the channels are here, including the new ones from Crypto Object. So it's just like Photoshop. Direct and indirect channels are added together. Start with a mix color node. Change the blending mode to add. Make a copy and set diffuse direct and diffuse indirect to be added. Do the same for the glossy channels, with both direct and indirect being added. Then we multiply the color channel on top of this result. Shift D to duplicate this node and change it to multiply. The result goes on top and the color goes underneath. Duplicate again with the result on top and the multiplication below. Then we have to add these two results. Let's see what we have so far. We started adding each of these channels. Then we multiplied the color up here and down there. And then we added the two. The image is practically done. Not look at the lamp in the left corner. We also have to add the other effects like emission. So, duplicate that node that is adding and bring the emission to this lower input. We can organize these nodes a bit with Shift and the right mouse button. This creates a point in space for us to manipulate these lines. Let's get really close to these areas with the render noise to see what can be done. With the magic of denoising, we will add the node called Denoise and bring the appropriate channels to this node, the normal and the albedo. While I was fixing these lines, you saw the denoise working in the background, leaving everything perfect without any noise. Look at this wonder. Perfect, huh? Everything we've done up to this point is just the result of the original render, nothing new. In this setup, it's possible to make the same adjustments that we did in Photoshop. I'm going to skip this part to make it less repetitive. But if you want to do the denoise on individual pieces, just follow the denoising workflow of the other chapter. I only did it on these first two channels to show that it is exactly the same process. We've already seen how slow this process is, and it's usually a waste of time. So I'll ignore this and keep using only the denoise at the end. Before we continue, I will enable the backdrop for us to see one last time. I only cleaned these two channels and it already took too much time in my opinion. I would have to do it again and again if I wanted to continue using this workflow. I'll delete all of this so we can return to the previous methodology. Ctrl-X removes the nodes without deleting the connection between them. I can connect this last denoise and connect the viewer to it once more and wait just a little bit longer. But at least it's just a denoise node. Now we can return to the most important thing, which is the cryptomat, because this is what I wish you to learn. We just add the node called cryptomat. Clicking the plus button, we can directly select in the render the object we want to isolate. I'll start with the plants. If you were working with that other workflow that starts with the clean Blender scene, you would need to switch from render to image, select your image, and then it will perfectly read the cryptomat channel. In my example, I will use render because that's what we're doing. We can also visualize it with Ctrl-Shift. Look at this marvel. Different from the object selection like we did with the index pass in the past, it will perfectly select even objects that have depth of field or motion blur. I already have the plant selected, so let's test changing its color with the hue saturation node. I will open up a space because we'll need it later. The cryptomat comes right after the end of the initial composition. Now with this additional space, let's create two more nodes. A mix node and a hue saturation node. The final composition will connect in two places first, in the hue saturation itself, and then in the top channel of the mix node. I will create a few more of these points to go around the cryptomat. The matte channel of the cryptomat will go into the factor channel of the mix node. We can visualize it and see what happens when we adjust this hue saturation. How wonderful! Without this mask, the hue saturation would alter the entire image. But thanks to the mask that cryptomat generates, based on the object we selected earlier, we have perfect control. Even objects with depth of field will have their masks created perfectly, with all the depth and blur of the original render. Even if I exaggerate with the values of the hue saturation, those edges we saw in Photoshop won't happen here. It's much more than a selection based on pixels. With the node selected and pressing backspace, we return to its default properties. And now I can make the change that I really want: a bit more saturation, maybe 20%, and adjust the intensity of the plants as well. This way, it becomes a much richer green. If you want to do this with other objects, it's the same setup. I'm going to delete this viewer, duplicate all of this, and do it with one more object. Click the minus sign to remove this selection, and on the plus sign to add, maybe, the chair now. Randomly tweak to see if it works, and it's working. Now with a little more care, what can we do? Maybe change its color. The idea here is not to make something beautiful, but actually show how powerful this tool is. No weird edges, even though I exaggerated quite a bit with the color changes of this object. It's really impressive. If I really want full control, I prefer to use this method rather than doing all that in Photoshop and still achieve a limited result in the end. And now we add this denoise, and with the image completely clean, thanks to it we can copy this entire grading setup, which will come last, for that super necessary color correction in all projects. Since I already have all this set up, there's no problem leaving the denoise on. But any change I make will require it to recalculate this node. So it's ideal that, while you're adjusting things, you select the node and press M. This way it ignores all the effects, and it's much faster to work with. And here is the final composition made entirely in Blender. And have you noticed how at no point did we need to talk about 32 bits or linear and none of that? That's because natively we were already working in 32 bits all the time, but with the color transformation only in the viewport. This is the tone mapper, which makes things look nice on the screen. We've already seen that too. You don't need to convert or worry about 8 bits, 16 bits, none of that. But we are at 3D Masterclass. So we go one step further. When turning off the view transform, the only thing that changes is the tone mapper of the screen. We've seen this 50 times already. Visually broken, but mathematically correct. The tone mapper in color management comes after the compositor. So all these nodes are applied first, and lastly the color management corrections. And it might feel strange to make corrections in two places, right?
No? Ninguém? Hello?
Well, I find it strange. So, to keep everything inside the compositor, let's set the view transform to standard mode. Let's also set the look to none, and I will leave the exposure at 0. And let's make our own tone mapper. I will place this custom tone mapper before the color corrections. Open up some space here, because we will need to place 4 nodes. And what are these 4 nodes? Exposure, gamma, and 2 curves. If you haven't noticed how it's just like Photoshop, I can no longer help you. Give up, man! Give up! With Denoise turned off, to make our lives easier and not have to keep waiting, let's connect all of this here. So these 4 nodes, as they are unchanged, the image is unchanged. It's coming out exactly as it did from that last mix node, only with the local changes of the cryptomatte and all the compositing we had done. But now let's find that sweet spot of contrast to then do the color correction last. First, exposure. And the idea of this exposure is to remove the values that were blown out in the original image. And you analyze this by looking for very strong highlights. And we've already done this so many times in this scene that I know the problem is with the vase and that screw of the lamp. -1 here, and let's look at the lamp now. Well, the screw isn't good yet. -2 then. Or -1.5 of exposure. We compensate with this gamma to make the image a bit brighter. I'll use 0.6 on the gamma. Looks okay. Now, the first curve for an overall brightness and the second curve will function as a contrast curve. Since most of the pixels are on the left side of the image, I cannot simply make a symmetrical S-curve. I need to concentrate more points on the left side on the graph. I already know this image quite well, plus we've done this several times as well. Once the tone mapper is finished, reconnect the color corrections in the event chain. I put viewer at the end. The colors turned out a bit different now because I did all of this out of order. First, the color correction after the tone mapper. So essentially, I have to fix my color correction because I have my own tone mapper. As we have already seen, it also alters the saturation of the colors and the intensity of the whites. That's why the image looks visually a little different, but luckily, I like this effect. It has more to do with my questionable artistic taste. I'll leave it like this. We turn on the Denoise one last time. And who would have thought? Who would have thought that everything would make so much sense? Only here, at
Remaster Clay.